Let's talk about nonlinear equations. We're going to start by just graphing. Now, what makes an equation linear? That's when you had the variable y and x, but they each had a power of 1. The moment one of the power changes, either on the x or the y, if you see in this example, you're no longer talking about a linear equation. And they're all going to be a little different. That's why we just call them nonlinear. Now, each one of these does have a name attached to it, but for now, we're just going to look at this first one that eventually does have the name of a quadratic. Now, for linear equations, all you needed was 2 points and you have your line. But when it comes to nonlinear equations, we might need multiple points to determine what our graph is. And sometimes some of the first numbers we choose is 1, 2, 3. Right? We always choose nice ones. But I don't know where that graph is here on this coordinate system. So you want to choose more numbers. Then maybe on both sides. Smaller ones, bigger ones. So that you feel that you have the correct image of that graph. So we're going to do that by taking this 1 for the x and plugging it in to our equation. That's going to be y is equal to 1 squared. And 1 squared is just going to be 1, so our y is 1. And then that pattern is going to continue. We're going to essentially say 2 squared. That's going to give me 4. We're going to plug in 3. 3 squared. 3 squared is going to give us 9. And maybe you can slowly see that what we're doing to this x is squaring it. 0 squared is 0. Now this one you have to be careful when it comes to negatives. Don't just write negative 1 squared versus negative 1 quantity squared. Now, what we're doing in this example is negative 1 in parentheses squared, not negative 1 then squared. The main difference is because this means that you're going to take the 1 and multiply it to itself. That negative is just lingering outside, versus in this one, it means negative 1 times negative 1. One leaves you with negative 1 as an answer. The other one leaves you with positive 1 as an answer. So that means this problem is going to be positive 1. Same thing. We're going to take that negative 2 in parentheses. It's going to give us positive 4. That negative 3 is going to give us a positive 9. Now, I just plot these points, and I hope this is enough points to help me see this graph. So starting with that very first point, I'm going to have a point at 1, 1. I'm going to have a point at 2 and 4. Have a point at 3 and 9, which would actually be 2, 4, 6, 8, somewhere all the way up here. Negative 1 and 1, negative 2 and 4, and then negative 3 and 9, which is somewhere up here. I might not be able to see all of them, but oh, and we forgot a very important one. The 0, 0. And that point is right here at the origin. Now, if you didn't have all these points, you might think, oh, this shape might make a V, or maybe it's still a line. But these points help us see that it's kind of coming down. Now, what we don't know, is it in a straight line? Is it in a curved line? And if you can't tell, you can start choosing more points, right? This is 1, and that's 0. So you can go and choose 1/2. what happens when we do 1/2 squared? It's going to be 1/4. So that's going to mean at a half, this becomes a quarter. And you can see now, it's definitely not a straight line. And it's not just a little curve. It looks like there's a substantial amount of curve. If I'm going to get to this point to the next point, it's definitely more curvy. I can even go one step further and see, well, what does it look like if I were to do 1/3? 1/3 squared will give me 1/9. And that point, if I were to really zoom in, 1/3 1/3 is approximately here. 1/9 is going to be really, really low to the x-axis. So even though this might look like it's a straight line, starting from the origin out, this is actually really close to the x-axis and then begins to turn. And that's important because without that, we might have just done a very sharp turn. But now we know that there's a lot more curvature in this problem than we can see. So it starts by going outward and then starting to curve up. And the name of this graph is actually a parabola. And there's our first nonlinear function. Now here's our second one that looks very similar. But now my y is being squared. Let's see what difference that makes. Now I know in the last example I chose all these different x's. But the problem is if I were to plug into x right now, the only way to solve for y is I need to apply a square root property, which we haven't really talked about much in square roots. So in this case, it's actually better if we choose our y values and that help us get our x, because if I plug into y, I can square the value already. And we saw that 1 squared is going to give us 1. And then 2 squared is going to give us 4. 3 squared is 9. 0 is still 0. Negative 1 squared is 1. Negative 2 squared is 4. Negative 3 squared is 9. And if you want to throw a negative half, that's going to be negative 1/4. Now, I can take these points and plot them. So I have a point at 0, 0. I have a point at 4 and 2, so 4 and then go up 2. 1 at 0, 0, which is the origin. I have 1 at 4 and negative 2. And we have 1 at 9 and negative 3, so 2, 4, 6, 8, 9, and then 3. It's somewhere around here. And same thing for this one. If I did 9, I'd have to then go up 3. So that would be about here. And then there's a negative 1 and 1, which is looking like it's going to be the same pattern. So I can sketch the graph this way. And now it's just giving me when the y is squared, it's actually giving me a parabola that is sideways versus upward. Again, still similar because we're talking about one being squared and the other one not. Still creates this graph. And let's look at another example, which is the absolute value. Let's not forget, for absolute value, the outcome is always positive. But let's choose some points. Now, I don't want to be plugging into y this time because I have no way of figuring out how to solve for the absolute value, or solve for x with the absolute value being here. Quickly, at least, because if we do absolute value, let's say if I did choose a 1 for your y, that means the absolute value of x equals 1. But don't forget, before when you're solving absolute value equations, when your absolute value is isolated, you look you look to make sure there's no zero or negatives. And then when you remove the parentheses, you create two equations. Two linear equations, one equal to x and one equal to 1, another one equal to negative 1. So one potential answer is 1, and there's another answer at negative 1. All right, that's how we solve the absolute value equations. Now, if you want to avoid doing all this extra work, you can just choose numbers. So for example, 2, that means y is equal to the absolute value of 2, which is 2. 3, the absolute value of 3 is 3. And then 0 is 0. Absolute value of negative 2 is also positive 2. And then if you plug in that x, absolute value gives you 3. We have them plugged in. It's easier to plug into your x's. So absolute value of negative 2 is 2. Let's see what this graph is making. So we have a point at 1 and 1, like usual so far, at negative 1 and 1, at 2 and 2, at 3 and 3, 0, 0, negative 2 and 2. I could have used negative 3 and 3 as another point. Absolute value of negative 3 is positive 3. We saw that already. So that would be a point right up here. If you notice, these are all pretty lined up with each other. And that's because they make this shape of the graph. They make a V shape. And there's our absolute value function, equation. And then one more is when we have a cube. So see the difference is very similar to that square one we did, but this one has a cube. And that cube is going to create a different graph other than the square did. Once again, it's going to be easier plugging into x's because that has the operation versus isolating the operation. So 1 cube, meaning 1 times 1 times 1 is going to be 1. And plug in 2. 2 cubed is going to be 8. 3 is 27. We got our 0 zeros. And then maybe we can pick some negative ones. Negative 1 and negative 1. Negative 2 and negative 2. Oh, sorry. Negative 8. So if I start plotting some of these points, and again, I'm just taking these values and plugging it into x. 1 cubed is 1. 2 cubed is 8. And so on and so forth. So now, let's plot some of these points. So, 1, 1, 2, and 8 actually puts a point all the way up here. Because this is 1, 2, 3, 4, 5, 6, 7, 8. We have 1 at 0, 0, negative 1, negative 1, then negative 2 and 8. So 2, 4, 6, 8. Now, let's sketch this graph. Has a curve here and a curve here. And there is what our x cubed looks like. Almost looks like an actual S. or sorry, 2, but looks almost like an S, right? It feels like this, or reverse S. Now, what am I going to be doing with these? One quick, small introduction that we will look more in detail later in 3.5, but a quick one is looking at simple transformations. So this is if there's a constant being applied within the equation slash function, and that moves things left to right, but when they're inside, it actually moves opposite of things. So positive actually moves it to the left, negative moves it to the right. And now things are outside, look like this: negative x, negative plus x, not within some parentheses. It's outside. The reflection happens on the x-axis, and then any constant just moves the graph either up or down. So positive moves left, negative moves right. So the first example we're going to sketch is this absolute value. But before we sketch it, you have to recognize that this is an absolute value function. Sure, there's other things going on, it might change it later, but it's still I don't know if I have it here. But we want to make sure we know what graph it's going to be, and looking at this, the absolute value makes a V. So I'm not going to sketch it right away, but I do know roughly what it should look like. So here, you always want to start with your parent function. So you start with your parent function. Then we have to look if anything's multiplying to the x inside, and there isn't. There's only this negative 3. And that's actually going to move the graph 3 units to the right. Remember, negative goes to the right, positive goes to the left. So it's going to move to right here, negative 3. So this is now with the absolute value part. And that negative 3 is actually going to move it to the right by 3, which it did. And it moves all the other points as well. And then that negative 2 brings it down by 2. Or I can input that point here. So we started with the parent function. You got move left. And move to the right. So this graph, all it did, because of that negative 3, is not move to the left, it actually moves 3 to the right. Now this negative 2 just brings everything down by 2. So it's going to look like this. And that'll be all. Those are your 3 different graphs. It moved to the right, and it moved down. Let's do a couple more. You can always pause, try to find these graphs. Now remember, the y has a power of 1, the x has a power of 2. So this tells me it's going, my parent function is going to be a parabola. And that parabola is just a starting point for this graph. I need to start with anything adding or subtracting inside. This is not in parentheses, but there is something multiplying. That negative just reflects the car down, or sorry, not the car. Reflects the graph downward, and then from downward it actually shifts it up. I'm just going to copy this, and then I'm going to shift the whole thing upward. It just shifts up by 1, and that's all we need. We had the parabola, we had the reflection, and then we had it shift up. Again, we're just doing entry level ones. Here's a cube. The cube means it's going to have that squiggly S. Now, a way to really see that, how am I going to remember all these graphs? Well, the idea is we're just trying to get a rough sketch. We're not a perfect graph. Now, you can get some points that, if you notice, some of these graphs all recognize. And that point is 0, 0, and 1, 1. And I have my points here, 0, 0, 1, 1. And then here too, 0, 0, 1, 1. But I have to look at these key indicators to tell me the type of graph I'm going to be dealing with. So since this is a cube, I'm dealing with x cubed as my parent function. That's the original cube. That plus 2 is actually going to move it to the left by 2. And that moves to the left. Hopefully you recognize this is the y-axis. This is the y-axis here. It actually moved 2 to the left. And then the negative copy. So that made your graph. The 2 shifted it to the right. That negative is going to reflect it. So it's going to look like this. And that's for that negative outside. It does reflection. Lastly, I just need this whole graph to go up by 3, which is going to be right here. This is my graph. Oh, it's not this side. It goes up 3, but this part of the graph comes down this way. And the next part comes down this way. So the graph shifted over 2 to the right. And then up 3. So we have our original cube. Move to the right. We did our reflection. Now we just need to move up. This shouldn't be there, because it goes up by 3. The 3 it goes up by should be here. not this point here. We know that this is going to be an x cubed. It moved to the right by 2. It got reflected. Now I need to move up. And it's just as quick as writing the graph. Now we're going to go through this a little quicker. So again, we have the absolute value. We know that that one's going to be this way. We know the negative is going to reflect it. And you know the negative 3 is going to come down. It's going to come down 3. So 1, 2, 3. It's going to come here. Here is my graph. So absolute value x is my parent function. The negative reflects it. And then the other negative brought it down by 3. And one more. There's another one of that absolute value. Oh, sorry, the cube. There's a cube here. Cube here. Remember, inside does opposite of everything, so negative 2 actually moves it to the right by 2. So move 2 to the right. So that just moved it to the right, and then we gotta move it up by 2. So that's gonna be 1, 2, right here. Just goes up by 2, and the graph is going to look like this. And here is our graphs for non-linear functions.